Hi, everybody. I want to take this opportunity or use this video to show you how I did homework 3. And yeah, let's get that homework assignment up on the screen. So here is the homework assignment. Again, I will leave it to you to look at the things that we want to be able to do and read a little bit of notes. The ones we're going to be doing, and I'm just noticing that I didn't put the chapter on there, and I put this in a different order than I did in other. I gotta fix up my my assignments. Sorry, I'll clean them up a little bit. Anyway, we're gonna be doing these problems right here. So let's. I've gone ahead and done them already. I'm not gonna be typing this as we go. Right, I've got this, and I've got my I got this guy here, the chart, which is a bit of a mess. I got stuff kind of going everywhere. But let's go ahead and look at the questions. So we're going to start with 43 through 45. Oops, where's that guy? Yeah. All right. So 43 through 45. Where are we at? All right. So use the following information to answer the next 3 exercises. This is the length of boats moored in a marina. We want to calculate the mean, median, and mode. So what I did was I just typed all of these things into Google Sheets. I just typed this all 16 through, come on, highlight. Yeah, these guys right here. Typed them all into Google Sheets. That's in my data. What am I doing here? This one? Yeah, this one. Right, so I just put them all right here. This is that stuff. And then I found the mean, median, and mode. I also found the standard deviation before I realized that the question didn't ask for it. I just left it in there. It was simpler to leave it than delete it. So, so to find the mean, I found the average. Again, I'm just using the commands in Google Sheets. You can certainly type this into your calculator and use one variable stats if you want. It will find all of these things for you, except the mode. It won't find the mode, unfortunately. You'd have to go do that yourself. It's not that hard to poke through and notice that there are 325s, and oh, there's some other ones too. 327s as well. It looks like Google Sheets just gives you the first one. But anyway, the mean, use the command average equals average of A1 through A27. Yep. And then mode, that command is equals mode. And the median is equals median. There you go. That's how you find them. You can definitely poke through here if you want to, but I don't want to. I want to have calculate. I want to have the computer do it. So that's what I did. So mean, median, mode. There you go. Problem 52. Oop. Does not help to click. I have to share differently. Sorry. 52. When the data are skewed left, what's the typical relationship between the mean and the median? So it means that the mean's to the left of the median. In general, the skewness is where you're going to find your outliers / unusual data points. And so the mean gets pulled in the direction of those. And the median does not. The median is just the middle value in your data. It does not care how big or small the endpoints are, but the mean does. And so when you have things that are far away from the middle, they pull the mean, but not the median. So in general, when the data is skewed left, the mean is to the left of the median. Problem 53. When the data is symmetrical, what's the relationship between the mean and the median? They're the same because they don't get pulled in either direction, or I guess you could say they get pulled equally, or the mean gets pulled equally in both directions and so doesn't move. And then 57 asks basically the same question, right? The relationship between the mean and median of this distribution. Well, this distribution is skewed to the right, so the mean is bigger than the median for the same reason as before. We have 74. 74. There we go. So I believe I asked you to make a box plot of this by hand, or excuse me, stem and leaf plot by hand. You can. I did it on the computer. You can certainly do it either way. It's not particularly hard. Is it this one? Yeah, it's this. So here's my stem and leaf plot. Stems, leaves. Right. So I've got 51, 76, 77, 78, 79, 81, 82, 84, 86, and 99. So that is Y looks like this, right? 51, 76, 77, 78, 79, 81, 82, 84, 86, and 99. So notice that I have included a category for 60s, even though there are no 60s, because I want the property that if I were to take this thing and tip it on its side, I would have a histogram. So that means that I have to include the categories that don't have any data in them, because it's important to see that separation between the 50s and the 70s, right? If I skip the 60s, it looks like the 50s are right next to the 70s, which of course they're not, right? They're separated by the 60s. What did I just do? Something, I don't know. So anyway, there's my stem and leaf. And then the other question, or part B, asks about which ones might be outliers, which is kind of a weird question. 51 and 99 maybe could be outliers. I'm fairly confident that 51 probably is an outlier. I didn't actually check. I would use the 1.5 times IQR method, right? We would find the interquartile range by doing Q3 minus Q1. We would multiply that by 1.5, and then we would go that distance below Q1 and above Q3. Anything outside of that range would be an outlier, which I believe 51 probably is, and probably 99 is not, but it might be, depending on how small the IQR is. Looks like the IQR might actually be relatively small. So it's possible that 99 is. I suspect 99 probably isn't, but it might be. We've got question, where are we at here? 78, this question. So 76, 77, 78, there we go. 25 randomly selected students were asked the number of movies they watched the previous week. 4 movies. It's a lot of movies in 1 week. Although I suppose this could be like movies at home. This is not you went to the cinema kind of thing. The results are as follows. There we go. 0, 1, 2, 3, 4 movies. Frequency of 5, 9, 6, 4, and 1. So 5 people watched no movies, 9 people watched 1, 6 watched 2, etc. Make a histogram of the data. Turns out this is actually very easy. Now, although you can't actually quite make a histogram of this data, what you've got here are categories, right? And the categories are only 1 unit wide, so you can't really make a good histogram of this. So we're really making a bar chart. It's the distinction is not especially important. Anyway, let's flip over to the data. So here's what my histogram looks like. Look there. There's what my histogram looks like. You can see this is technically a bar chart, right? 0, 1, 2, 3, 4 are each categories. If we go over the data, that is this. Now, here's the nice thing. All I did here was, if I just highlight these and tell it to make a chart, where's my chart? Tell it to make a chart. The first thing that pops up, hello? Computer, are we gonna make a chart? There we go, all right. Is the exact thing we wanted. I really love how good Sheets is at knowing what makes sense as a chart, right? So this is the chart I made. All I did was put a title on it. I just slapped a title on it and called it good. Yeah, that was all I had to do. It's great. Of course, you could just use Sheets to make your chart, right? We've seen this before. You just go through it, and you've got different kinds of charts, and you can customize it in various ways, etc. But it turns out that the first chart it makes is this one. Notice that's the one it was just showing. I just put a title on it and copy pasted it right in. Good times. And they also wanted me to finish filling out the table, which I did in red. Relative frequency, cumulative relative frequency, etc. So for relative frequency, I added all these up. How many? This was, or I guess they told us it was 25. So we had 5 out of 25 is 20%, 9 out of 25 is 36%, etc., etc., etc. And then for cumulative relative frequency, you just add these things up as you go, right? So 20% because there's only one category, 56% because it's the sum of these 2 categories, 80% is the, hello, no, click. 80% is the sum of these 3 categories, and so on and so forth till you have 200%. There you go. Okay, and then we've got 83. All right, so 83. Which one was that? Oh, this one. Yeah, that's one where I where the question that I asked on the homework was, don't do part C and then tell me why I said don't do it. There's good reason. So 600 people were asked, what do you think constitutes middle class income? Here are their answers and the percentages. We got under 20,000, 20 to 25, 25 to 30, et cetera, et cetera. And they ask what percentage answered not sure. Well, they don't have a category for that. So I'm going to presume that the only choices are these categories and not sure, right? That's those that there's not another category like declined estate or over $1 million or something like that that they're not showing in the chart. I'm just going to assume that it's just the things that they have in the chart plus the category not sure. They didn't say that was the case here, but I'm going to presume that that's what they meant. So if we add all these up, they add 94%. And so that means that then 6% are not sure. Wait, 94 or 96? 94. Yeah, 94% for all these, and so 6% are not sure. What percent think that the middle class? What percentage think that the middle class is from $25,000 to $50,000? Well, 25 to 50,000 is those categories right there. So we add up those. What's that? 37 and 26 is 53%, 63%, 63%. That's what I meant. Construct a histogram of the data. The instructions in the homework specifically said, don't construct a histogram. And then there's a bonus question for tell me why not. Well, let me tell you why I wouldn't do that. So see, I will not construct a histogram of the data. The categories are not of equal width, and so they would look ridiculous, especially the 100,000 and up category. That is an absurd category, right? Category technically stretches off to infinity, so your bar is infinity wide. That's dumb. When you're making a histogram, categories have to be the same width. Otherwise, the wider they are, the larger area in the x-axis they represent, and therefore the taller they would be relative to the same size category if you broke them down to. Boy, I said that awkwardly. So if you chopped up all the categories to be the same width, then the ones that you then made wider and put bars together would also makes them taller, and so you're not comparing apples to apples. It's not a reasonable way to make a histogram, so I won't do it. Instead, I made a bar chart. So let's see. I presume they asked me to do that. I wouldn't have made one if they didn't. So let's see what the questions were. Construct a bar graph there. Now this is an entire. Why is it not? This is an entirely reasonable thing to do. These are categories. These are qualitative categories, really. They're technically quantitative, but they're all different widths, so you don't want to make a histogram. So thinking of them as qualitative categories is totally fine. You can definitely do that. And then the bar heights are given by the relative frequencies here. But first, before we find that, we need to find the 40th and 80th percentiles, which is, it's tricky. You got to think about what it means, and you can't find them exactly. So here's what we need to do. What I need to do is so the 40th percentile is the value that has 40% of the data to the left of it, or smaller than it. So what I'm going to do is I'm going to add up the categories until it goes over 40%. And then I say that the 40th percentile is somewhere in there. So 2, 11, 30, 56. So 30% is below 30,000, and then 56% is below 40,000. So that means that somewhere between 30 and 40, we went over 40%. So therefore, that's my answer. My answer is that the 40th percentile is somewhere in this category, but I don't know where because I don't have enough. Why is it not highlighted? It's somewhere in this category, but I don't know. I can't pinpoint it precisely. All I know is it's somewhere in there. Same thing for the 80th percentile. Just keep going until you get over 80. What we said that was 30, 56. 74, 91. So that means that somewhere between 50 and 75 is where the 80th percentile is. And that's what I put in my answers. Construct a bar graph. I did that. It was very easy. So we went to, and it was very easy in the sense that Google Sheets knew exactly what I wanted to do. It was great. Let me share this up. So what I did was this. This is my data for that. I highlighted this and then I hit the chart button. And it gave me the chart I wanted. Bam, there it is. I put a title on it, copy pasted, and then we're done. Fantastic. I love Sheets charts. They're so good. Yeah, so you can see this is what I did. I also I did make one minor change, which I sort of objected to the way they, I actually objected to their category choices for the following reason. Delete that and go back here. So for their categories, they said under 20, 20 to 25, 25 to 30, totally reasonable. And then suddenly changed from 99,999 to 100,000 plus here. I don't know why they chose to put all the nines here, but not there. That's just weird. So I didn't. I just made this 75 to 100 and then 100 plus. So yeah, my chart is not technically labeled exactly the same as theirs. I think mine is labeled better. So that's what I've done. Let's see where are we at? Oh, it's telling me my previous recording is done converting. That's nice. Yeah, so you can see I went 75 to 100 instead of 75 to 99,999 because they didn't do that in the other categories. So why would I do it in the last one? So yeah, there you go. All right, next question. 84. All right, let's go look at 84. 84. Oh yes, the box plot ones. Okay, so these box plot ones are tricky to read. So just a quick refresher on box plots. This box plot here, it looks at first like 2 to 10 has most of the data in it, but that's not true at all. There's the same amount of data between 0 and 2, 2 and 10, 10 and 12, and 12 and 13. Because that's what the quarters are. The quartiles are at 2, 10, and 12, right? First quartile, second quartile, third quartile. That means 25% of the data is below this, 25% of the data is between 2 and 10, 25% of the data is between 10 and 12, and 25% of the data is between 12 and 13. Consequently, there's not more data in here. There is just sparser data in here. Okay, so which quarter has the smallest spread of data? 12 to 13. What is that spread? 1. Which quarter has the largest spread of data? The second one. What is that spread? 8. 2 to 10 is 8. Find the IQR. Q3 minus Q1 is 12 minus 2, it's 10. Are there more data in the interval 5 to 10 or the interval 10 to 13? There are more data in 10 to 13. 5 to 10 might look like it's bigger, right? 5 to 10 is a wider range than 10 to 13 is, but there's more data in 10 to 13 because literally half the data in here is between 10 and 13, but less than a quarter of the data is between 5 and 10, because a quarter of the data is between 2 and 10. So between 5 and 10, there's less than that. You could make up some weird data set where all the data between 2 and 10 is between 5 and 10, but we're ignoring that case. I'm just assuming this is a reasonably spread out data set. Which of these intervals has the fewest data in it? I hate the way they phrase that. The fewest data values, or the least data. Bad grammar. And how do we know this? So they give us 0 to 2, 2 to 4, 10 to 12, 12 to 13, or need more information. Technically, the answer is need more information because you could construct a weird data set, but really the answer is 2 to 4. And the reason it's 2 to 4 is same as we've been discussing. 25% of all the data in this study are between 0 and 2, and 25% are between 2 and 10. 25% are between 10 and 12, and 12 and 13. And so they give us 0 to 2 that contains 25% of the data, 10 and 12 that contains 25% of the data, 12 and 13 that contains 25% of the data, and 2 and 4 that contains less than 25% of the data. So it has the smallest amount of data values. There you go. That's how you can do. Next problem is 85. Here is the US population. I actually really like this question. Are there fewer or more children, 17 and under, than senior citizens, 65 and over? Again, it's a box plot. Each of these contains a quarter of the population, right? Each of those parts contains a quarter of the population. So a quarter of the population is under 17, a quarter of the population is between 17 and 33, a quarter of the population is between 33 and 50, and a quarter of the population is 50 to about 105. So are there more children or senior citizens? Well, 25% of the population is between 0 and 17, and 25% is between 50 and 105. So less than 25% is between 65 and 105. So there are more children. 12.6% are age 65 and over. What percent of the population are between 17 and 65? Well, if 12.5 or 12.6% are from 65 to 105, and 75% are from 17 to 105, right? 3/4 are from 17 to 105. Well, then I just take 17 to 105, the 75%, and minus the 12.6, and I get some number that I put on the other problem. So it's 75 minus 12.6, which is 62.4. That's about the 62.4% are in the 17 to 65 range. All right, problem 88 is the one about tell me why all these things are false. 88, okay. So incomplete sentences, explain why each statement is false. So here's the essential reason for all of these. They don't tell us how many things are in each data set. It's implied, like the implication by not having any sample sizes or any sample sizes on these things, the implication is that they're the same size, but they don't say that, right? So we could have 1,000 things in this data set and 100 things in this one, or vice versa, or they could be equal, but we can't tell. So data 1 has more data values above 2 than data 2 has above 2. Not necessarily true. Data 1 has 75% of its data values above 2, and data 2 has 50% of its data values above 2. But like I said, let's say I have 100 things in this data set and 1,000 things in this one, then there would be 500 values above 2 here and 75 values above 2 here, and so there would actually be more in data 2 in that case. So if the sizes of these, if we knew the sizes of the data sets were equal, then this statement would actually be true, right? Data 1 has 75% of its values above 2. Data 2 has 50% of its values above 2. So if there were the same number of data values in each set, then that statement would be true. But since they don't tell us that, we don't know. And so in math, we say it's either provably true or else it's false, right? And so since we can't prove that this is true, then we consider it false. Data sets cannot have the same mode. I don't see why not. Their modes could both be 3 or 5 or anything between 0 and 7, really, right? There's nothing saying that all these values between that looks like what, 2.5 and 7, they could all be 5. I don't know, and maybe all these are 5 too, and so their modes are both 5. Sure, that could happen. For data 1, there are more data values below 4 than there are above 4. False. There are the same number below 4 and above 4, because in data 1, the median is 4. So half the data is down here, half of it's up there. So there are the same number of values in both. It might look at first like there's more below 4 because the area down here is like this is wider than that, but that's not how you determine that, right? It's you determine it based on where the median is. So median's 4, same number above and below. And then, oh wait, did I get all of them? Oh yeah, for which group, data 1 or 2 is the value of 7 more likely to be an outlier? Well, we can in fact guarantee that 7 is an outlier in data 2. Like it is actually possible for us to tell that it is definitively an outlier in data 2. And here's how. So using the 1.5 times IQR method, if you go 1.5 times IQR above Q3 and anything outside of that is an outlier. Well, the IQR is literally the length from here, from Q1 to Q3. Like it's literally that distance right there is the IQR. So if I take that, so then one of those above, and then here's Q3. So if I go one of those above here, and then like 1.5 is like here, right? So this is 1.5 IQR above Q3, and 7's outside of that. So 7 is an outlier. That's it. And we can see here that in data 1 that 7's not an outlier, right? Because there is the length of the IQR. If I go that distance above Q3, I get something like this. So this is like 1 times the IQR. So 1.5 times IQR would be over here somewhere, right? So 7 is not an outlier in this case, at least by the 1.5 IQR. So more likely to be an outlier, there's a 100% chance that 7 is an outlier in data 2 and not in data 1. Did I answer that question? I didn't. I forgot I typed that in my answers. All right. And then the last, oh no, there's 2 more questions. One's 103 and then 115. So 103, oh yeah, 115 is huge. So 103, all right. 3 students are applying to the same graduate school. They came from schools with different grading systems, very different grading systems. Nobody has these grading systems. Which student had the best GPA when compared to other students at his school? His. Should it be his or her? I think we're all fairly familiar with Kamala being a woman's name. I don't know. I guess it could be a man's name. I don't know. Anyway, explain how you determined your answer. So the way we measure something relative to different things is by standard deviations. We measure them in standard deviations. So in each case, I want to know how many standard deviations above or below the mean for that person's school that student was. So Tui here has a GPA of 2.7 and the school's average GPA is 3.2. So Tui has a GPA that is 0.5 units lower than the school's average. Well, standard deviation is 0.8. So that means that Tui is 0.5 divided by 0.8, which is 0.625, standard deviations below the mean. So you could probably rule Tui out right off the bat because Tui here is below the average for his school, and Vishay and Kamala are, or Kamala probably, are above the averages for theirs. So right off the bat, Tui is right out, but Tui is 0.625 standard deviations below the mean for his school. Vishay is 12 GPA above his school's average. I don't know how this works. He's 12 GPA above his school's average. And the standard deviation is 20. So that's 12 out of 20, or 0.6 standard deviations above the average. All right, that's better than Tui at least. Kamala. I've got to get that right. Kamala is 0.6 GPA above, I'm going to say her school's average. But the standard deviation is only 0.4. So it's 0.6 divided by 0.4, which is 1.5. Kamala is 1.5 standard deviations above the mean for her school. So Vishay, despite being this, 12 GPA above for his school, that's only 0.6 standard deviations above. Kamala is 1.5 standard deviations above, and Tui is below average. So Kamala is the best student relative to other students at her school. All right, 115, that's the jumbo problem here. One about the football players. So here are the published weights of all the team members of the San Francisco 49ers from a previous year. I don't know why they don't just tell us the year, but they didn't. This is one previous year. This must be a while ago because there is, I believe, only one person over 300 pounds. There's like 1,302. This doesn't seem like it could possibly be right. Every offensive lineman is over 300 pounds now. Anyway, I guess some of the centers aren't, but anyway, that aside, let's go look at the data. The only way I knew to do this is to type it all into Google Sheets. You could also type it all into your calculator if you wanted to. I like Sheets for this, to be honest. So that's what I used. That is this one right here. As you can see, I jammed it all over here. Yeah, you can see they're all there. I typed them all in. They said, question 1 was organize the data from smallest to largest. So here's how I did that. I selected this, and then I go to data and sort range by this column from A to Z, and it'll do it smallest to largest, right? So if I go Z to A, that'll do largest to smallest, and you can see it's rearranged them so the big ones are at the top, but that's not what they asked for. They asked for smallest to largest, so there we go. Question 2, find the median, the first quartile, third quartile. So the median, obviously, as you can see, I found it by using the command median. And for the first quartile, I use the command quartile. I told it the data range here and 1. That tells it to do the first quartile. Third quartile, same thing, data range and 3. And then mean, I use the command average, and standard deviation, I use the command stdev for when those come up. Let's go look at the questions. First median, first quartile, third quartile. Box plot, I didn't make a box plot. As I've mentioned, Sheets is horrendous at box plots. Not going to make one in Sheets. It's nonsense how hard they do. You can do it by hand. We found the first quartile, third quartile, median, min, max, right? You put those on a number line, make a box plot. I'm not going to go into that here, but that's yeah. You can see that in the lecture on this for this homework. Middle 50% of the weights are between the first and third quartiles, right? It's the box part of the box plot, and so that is between say 206 and 272. Yeah. If our population were all professional football players, would this be a sample or a population? Sample. It's not all of them. This is just one team. If our population included every team member who ever played for the 49ers, would the above data be sample or population? It would be a sample, because this is not all the people who ever played for the 49ers. This is 1 year. 49ers have been playing since the 50s, probably, so for like 60 plus years. So yeah, this isn't all of them. This is just a single year, so it's a sample. Assume that the population was the San Francisco 49ers. I presume they mean the San Francisco 49ers this year, despite the previous question specifically saying what if it was all of them, or what if it was all the years. But I'm going to assume that they mean that it was just this year, because otherwise you can't find these things. So population mean, I use the command average in Sheets. Standard deviation, I use the command stdev. And I got these numbers, 236.34 and 37.86. Next question, the weight that is 2 standard deviations below the mean. So what we would do is take the mean and subtract off 2 times that. So, right, so took the mean right here, and then we subtracted off 2 times the standard deviation, and this is what you come up with if you do that, 160.62. At least that's what I came up with. And the next question starts asking questions about Steve Young and Emmitt Smith. So that presumably narrows down the year to the late 90s. What do I guess? Maybe 95-ish, something like that. All right, so find when Steve Young played football, he weighed 205 pounds. How many standard deviations above or below the mean was he? So what you want to do is the same thing we did for the Vichy, Toy, and Kamala question. We want to find out how far he was above the mean in pounds, and then divide by the standard deviation to find how many standard deviations it was. And when we do that, we get some number that I found already and don't want to recalculate. I get this. So Steve Young is this many pounds below the mean, right? So he is what's that, 31.34 pounds below the mean, divided by 37.86, which is the size of standard deviation, which gives me 0.83 standard deviations below the mean. Then you do the same calculation for Emmitt Smith. They give you all this information. Emmitt was 0.7 standard deviations below the mean. So Steve Young was more standard deviations below the mean for his team than Emmitt Smith was for his team. So Steve Young is the lighter of the two relative to their teams. And then we get bonus questions. So let's let me make sure that I've got everything there. Yeah. All right. So bonus question 1 was why don't we make a histogram in 83? It's because the bars would be different widths, which is nonsense in a histogram. Don't do that. And then bonus question 2, one of my favorites. Let's go ahead and share this here. The question was why in problem 119, what is useless about the sample, right? And don't do 119, just look at the sample and think about why it's pointless for its stated purpose. So let's go look at 119 and talk about it. 119. So here is a bunch of enrollment data at 35 community colleges across the United States. And it should be relatively apparent, or should be pretty easily apparent, these are very disparate colleges, right? There's a college that only has 1,263 students. There's another college that has 28,165 students. So these are kind of all over the place. All right, so I am taking this to be the purpose of like, why are we doing this? Yeah, so if we were going to build a new community college, what piece of information would be more valuable, the mode or the mean? The answer is neither of them. They're both pointless, given what we've got here. So here's why this is stupid. This appears to be a semi-random, so they don't actually tell me what kind of sample this is of colleges across the United States. I presume it is random. I don't know. They don't say. And they're asking me if I'm building a new community college, what piece of information would be valuable? And the answer is nothing, because I have no idea which of these colleges are similar to the one that I am going to build. Also, enrollment data is probably not relevant to what I am doing. The thing that I'm going to care about is how much land do I have? How much money do I have? How many classrooms will that money buy me? Right? Which majors are going to be really important? Are there local industries? Am I doing this in the middle of Iowa, and therefore I'm going to want to concentrate on farming, or middle of rural Iowa, I'll say, and therefore I'm probably going to want to concentrate on a lot of things relative to farming? Or am I doing this in the middle of Silicon Valley, in which case I should be all technical college based, right? And those are going to have very different costs very different costs of classroom sizes, right? In Iowa, I'm going to need a ton of land to farm on and to get practical experience. And in Silicon Valley, I need to get a bunch of computers, because that's what we're going to be doing. And I'm going to need to concentrate more on math in one area and more on agronomy in the other area. And so this sample that we've got here tells me nothing about what kind of college I am attempting to make. And probably the various enrollments that we have here have to do with whether the college is urban or suburban or rural, whether it's concentrating on agriculture or transferring students, or technical certificates, like, for instance, at SBCC, marine diving, right? I probably don't need a marine diving department in the middle of Kansas, but I might need one if I'm in Florida, et cetera, et cetera, et cetera, right? None of this tells me how much money I've got, how much land I've got, how many buildings, etc. So this data is completely useless. Also, if you wanted data like this to see, like, what's the average community college size in the United States, you can just look up all the community colleges, right? That data is available for every community college. You don't need to take a sample, right? Don't take 35 random ones. If you want to know what the average is, go find all of them and average those. Yeah, it'll take a little longer to gather, but not that much longer, right? It's relatively easy to do for California, which has the most. Probably relatively easy to do in Missouri and Montana and Maine, Virginia, and like, you just get all of them and put them all together. So yeah, that's why this sample is dumb. This doesn't tell you anything about what you would want to know for if you were building a new community college. And which piece of information would be more valuable, the mode or the bean? I really have no idea. I wouldn't want to know either one, to be honest. I would want to have a survey, a client survey, basically, of how many students can I expect? What things are we concentrating on? Anyway, you get the idea. This is way too general for building a specific community college, right? Don't get general data to do something specific. Get things that are relevant to your specific endeavor, especially if it's going to be something like some huge investment like building a community college. Like, for instance, SBCC's annual budget is in the general vicinity of $90 million, right? We've got 600 to 700 teachers at any given time, about 300 of which are full-time, and then 300 to 400 of which it's actually like 250 full-time, and then like 350 to 400 part-time. And a similar number, not exactly the same, but similar number of administrators and staff. And so you've got something like 12 to 1,300 employees on a $90 million a year budget. And that's not counting building the buildings, right? So you're talking several $100 million probably to get this set up, 300-400 million, something like that. Let's not just take a random survey of 35 colleges and say, yeah, this will be close enough. It's not a good strategy. It's a good way to waste a lot of money. Anyway, that's way more of a tangent than I needed for that question, but the sample irritated me, so I wanted to go off on it. Anyway, I think that's all I want to say about this homework. I'm going to go ahead and stop sharing and end my video. Yes. All right. I'm going to go ahead and end the video, and I will see you guys in the next one.